Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss balancing of redox reaction by half reaction method. Last class I discussed oxidation number method, balancing of redox reaction by oxidation number method. Today I am going to discuss half reaction method. This is somewhat easy in comparison to the oxidation number method. I told you there are two methods for balancing redox reaction, ionic reaction. Then here comparatively that you have seen that balancing of redox reaction by oxidation number method is difficult. Okay, but here you will find comparatively less. But even in oxidation number method also, that main things are there. I am just briefing it that first to balance the atom. If Cr2 is there already given and the product side only Cr is there, then make it 2Cr. Okay, means like that way, means oxidation process. Compare the oxidation process. How many electrons lost? That is the oxidation process, loss of electron. Then that you know that electron loss, that is the processes, oxidation process, and who lost, that is called a reducing agent. Reducing agent, and reverse is oxidizing agent, who will take the electron, that is the oxidizing, and process is reduction. Just reverse way keep mind. Reduction means that someone is taking electron, and that is the oxidizing agent. Reverse name is reverse of process, and oxidation is going on, which who one is losing, that is a reduction. That is called reduction. Reduction means also loss, that you know. Then that is a process is oxidation, and that atom is reducing agent. Like that way, reverse way, who is taking electron, that is a oxidizing agent, and process is reduction. Okay, then here in that process method, first atom you balance, who is oxidizing. After the you can say oxidizing, what is the change of oxidation number, that you keep in mind. A simple way I am telling you. Suppose Zn lost 2 electron, then it will form Zn 2 plus, means plus 2. Oxidation number is plus 2. And in the beginning Zn was 0. Now Zn is plus 2. And there is a loss of 2 electron. Like that way, suppose copper was there. Copper ion was there. Copper ion Cu2 plus was there. Now they have taken the electron. Now copper ion has taken the electron. The Zn became Zn plus plus, or you can tell Zn2 plus oxidation number. Now that is the oxidation, and Zn is called reducing agent. And in reverse case, copper is taking electron. Then copper is oxidizing agent, which it accepts the electron, and processes oxidation. The Zn, you compare Zn condition, Zn became Zn2 plus, means there is a loss of 2 electron. And what is this now? Think about the oxidizing agent, means copper ion. That will, copper ion, suppose 2 plus was there, plus 2 oxidation number was there, that it will take the 2 electron. Then now copper plus 2 now became copper. Then now here you see that Zn has lost 2 electron. Okay, then down the Zn, just simply I am telling for quick understanding, Zn is 2 electron, lost 2 electron. Copper ion has taken 2 electron. Correct? Then means one lost 2, other got 2. That's why coefficient will be 1, 1 only. No 2, no 3, 1, 1. Means when you write or not write, that depends upon you. Correct? Then always who is losing the electron and who is gaining the electron, how much reducing agent is losing and how much oxidizing agent is gaining, that you have to see, you have to see in the reaction, in expression or reaction, that you have to find out how many reducing agent lost the electron, how many oxidizing agent got the electron. If this you are knowing, then suppose one is losing 2, other is 3, gaining 3. Then now you have to equate it, because electron should be balanced. That's why here when you have, suppose a ratio is 2:3, then reverse way you have to multiply. To equate the electrons, then you have to multiply like this way. Number of electrons should be equal. Loss or gain. Loss of electron, gain of electron should be equal. Then suppose reducing agent got 3 electron, and this reducing agent lost 2 electron and oxidizing agent got 3. Then you have to balance this. Then how will you balance? It should be equal. Then how? Then 3 you multiply by 2 and 2 you multiply by 3 in a reverse case. Correct? Then reducing agent lost 2, and but here oxidizing agent got 3. Then it will not like that. It should be equal only, because you are considering atom wise, but balanced equation you have to write. Then for that purpose, that you do like that, number of electron should be equal. Means lost or gain must be equal. That's why this side who lost 2 electron, then multiply their 3, and here who got 3 multiply by 2, then both sides will be equal. Then that will be the coefficient. Means reducing agent 2 into reducing agent. Suppose Zn was a reducing agent, then 2 into Zn, 2 Zn, and suppose other oxidizing was there, then that will be coefficient will come 3. Suppose it was any other aluminum like that, then 3 aluminum. This is the balanced this electron wise. And after that, now if it is a acid medium, then add H ion. If it is a basic medium, add OH ion. And after that, to balance the H ion, you have to write H2O opposite. Suppose right side you have added H, then left side you write H2O. Okay, after that it should be balanced, hydrogen should be balanced. Like that way, OH also it should be balanced, because in OH, O and H both are there. Then H2O you have to introduce. You have to introduce H2O. Then like that way, again you have to add balance. You have to balance the hydrogen. Automatically after this you will see that H and O will be balanced. Electron is also balanced. Correct? Then final reaction you write. This is the shortcut method I told for this oxidation number method. Okay, to balance the redox reaction or ionic reaction. Here half reaction method is also easy. It is more easy than oxidation number method. Okay, because 5 steps I told you that you have to follow. Here also you understand like this way only, same example, and all things you can say in every reaction same things you have to follow. Okay, but easy example first I will tell you, and then other example also. In that also main process will be this only. Okay, only you can say automatically first to understand. I will give you an example. That same way it will apply for others also. Only balancing is required, atom by balancing. Here what you will do, just I have told you also, lead and copper example only I am taking you. Then you know that in any reaction, in any redox reaction, there will be oxidation and reduction. Both, not only oxidation, not only reduction. Oxidation and reduction takes place simultaneously, means together. One will lose the electron, same time other will take the electron. Means if reducing oxidizing agent is ready, then means it is attracting electron. It is attracting. That's why automatically reducing agent is losing, and oxidizing agent is gaining. Just like you are paying money, other person cash you are giving, or you are giving, other is taking. Otherwise simply you will not give. Some person should be there, only then you will hand over. Correct? Then you have given, then you are reducing agent. Other person has taken, that is the oxidizing agent. Then you have given the money, then oxidation, and that person has taken money, that is the reduction. Very simple way. Then here you can understand very easily that Zn, in suppose Zn reaction is going on between the ZnSO4 plus copper sulfate, or Zn plus copper ion, just to understand. Then Zn will lose the electron, means Zn will oxidize. Zn will lose the electron, means it will oxidize. After losing the electron, it is called oxidized. After gaining the electron, it is called reduced. Correct? Should not be in confusion. After losing the electron, oxidation process is going on, it is called oxidized, means it lost. Oxidized means it lost. And those who got the electron, reduced. Reduction process, reduced. Oxidation process, oxidized. Oxidation process, oxidized. Reduction process, reduced. Okay? And oxidizing agent, reducing agent, already told you. Those who are accepting electron, means reduction process, that is called oxidizing agent. And oxidation process, reducing agent. Okay, who is losing. Then here Zn is Zn, and I am talking about the Zn plus copper sulfate reaction is going on. Suppose Zn plus copper sulfate, then it will form ZnSO4 plus copper. Okay, this is the reaction. Now suppose you want to, already it is balanced, but I am telling you how in this method, half reaction method, how will you prove that these things happened? Or like that way, other complicated reaction also you can balance it. Then in any reaction, two process will be there: oxidation process, another reduction process. Both process will take place. Then oxidation process is called half reaction, and reduction process is called half reaction, another half. Half plus half, full reaction. That is called net reaction. Then here, that complete reaction in a equation what you are writing, now both reaction is going on. Then now you have to separate this reaction in two parts. First oxidation and second reduction. Then now oxidation is first to come. Zn is losing the electron. Then Zn, write the Zn arrow sign, and Zn is becoming Zn 2 plus, Zn ion, Zn 2 plus, Zn plus 2 electron it lost. This process is called oxidation. Zn was Zn metal, now it lost 2 electron. Then Zn, now it became Zn plus zinc ion plus 2 electron. This you can tell that is the half reaction, oxidation half reaction. It lost 2 electron. Now this 2 electron who will take? Then copper sulfate was there. Then in solution copper sulfate will be in the form of copper ion Cu plus SO4 2 minus. Cu2 plus cupric ion, that is called cupric ion. Cu2 plus means Cu plus SO4 2 minus. In solution copper sulfate will be like this. Then this copper ion, now this copper ion will take that 2 electron. Taking electron, now it is reduction. Then now second part you are writing Cu plus which was in the solution with copper sulfate. That Cu plus will take this 2 electron. Zinc lost 2 electron. That 2 electron this copper ion will take, cupric ion will take. And after taking, because 2 positive charge was there, Cu plus 2 positive. Now 2 electron it is taking, then charge is neutralized. It will give copper metal. Copper solid also you can tell. Copper solid or copper metal. Then this is the half reduction reaction. This is called half reduction reaction. First one was half oxidation, means oxidation reaction, and this is the reduction reaction, half. Now if you will add both oxidation reaction and reduction reaction, if you will add both, then what will happen? That electron was, for oxidation process, electron was in the right side. Now copper has taken 2 electron, now it is left side. Then if we will add both, oxidation and reduction reaction, then electron will be cancelled. Both electron, 2 electron will be cancelled. Okay, because if you take to the electron to the right, then it will become minus 2 electron, upside is plus 2 electron. It will be cancelled. Or simply you can cut left side, right side electron, both electron will be cancelled. Then now you are adding, then what will be the total reaction? Then upside Zn was there, upside means left side Zn was there, and down left side copper ion was there. Hence left side you have written Zn plus copper, Cu plus left side equal to right side what was there? In oxidation Zn plus was there. Okay, and now for the reduction, right side what was remaining? Copper solid, then plus Cu. Hence you got balanced equation Zn plus Cu plus that is equal to Cu plus Zn 2 plus. What was the left side? Write the left side. Both. For both oxidation reduction, what was the left side? Write left side. What was the right side? For both reaction, you write there. Right side. Then final reaction you got Zn plus Cu2 plus, Zn plus Cu2 plus, that is equal to Zn plus copper solid. This is the balanced net reaction. All things are balanced. Then here I have told you this is the simple reaction. Same way all other reaction also will take place. But there sometimes electron you have to balance. Now it was okay. See, 2 electron lost, 2 electron got. Quickly you have written. But now in some reaction you will find that in oxidation process 3 electron it is losing, and reduction process only 2 electron it is taking. Then now here in half reaction method, in final equation, electron should not be visible. There should be no electron. Electron must be cancelled. Okay, what I have told in the case of that also. There also it was not appearing. Here also finally it should not appear. In both electron should not be appear in final equation. Okay, then here many reaction will be like that. You have to equate, because electron you have to cancel. Oxidation time electron, reaction time electron, both should be cancelled. It should not appear in the final equation. For that purpose, you have to multiply in such a way that electron should be equal. Okay, then oxidation process time, there also have to multiply, and reduction also you have to multiply. And a complete oxidation side, left and right, you have to automatically you will multiply. That will multiply for both, for reactant and product. Okay, for oxidation and for the reduction also you have to multiply. Then left automatically you will multiply. Then it is for both left and right, means reactant and product. Then suppose I told you example that oxidation is 2 electron it is losing, 3 electron it is losing, and reduction size 2 electron is gaining. Then it should be 6. If you will both we want to cancel, then 3 upside 3 electron was there. Then 3 you multiply with reduction. Then the reduction side 2 electron was there, 3 into 2, and you multiply upside with 2. Then now it becomes 6 electron. Then you can cancel easily. Then this process is common. Okay, you have to do. Now I am giving you that one example that is somewhat little difficult. Process is same things, but now you will feel it is not simple reaction. Then here I am telling you, suppose you have to balance the equation showing the you can say oxidation of ferrous Fe plus Fe2 plus. Fe2 plus, suppose it is converting to Fe3 plus, means oxidation process. Fe2 plus it is converting to Fe3 plus. Then here it has lost 1 electron. Fe2 plus, now after the arrow sign you can write Fe2 plus 1 electron, because Fe lost 1 electron. Then now Fe2 plus became Fe3 plus 1 electron. This is the oxidation process. Fe2 plus was there. Now it converted Fe3 plus 1 electron, because this electron from the Fe2 plus gone. Now it became Fe3 plus 1 electron. This is the oxidation process. Okay. Now oxidation process you have written. Now come to the, you can say, suppose dichromate was there. Dichromate iron and dichromate iron was reacting. Cr2O7. Suppose Cr2O7 2 minus. Actually it is a K2Cr27. Suppose K2 gone with 2 positive charge. Then Cr2O7 2 negative will remain, because 2 positive gone. Then 2 positive in the molecule, remaining molecule will remain. That is called iron. Then Cr2O7. Who will take the electron? Iron has lost the electron, 1 electron. Okay, per atom I am talking about, 1 electron lost. Now this electron will be taken by Cr2O7. 2 minus is there, that will take this electron. Correct? Because see, Fe became now reducing agent because it is losing electron. Correct? And this electron will be taken by chromate Cr2O7 2 minus. Then now this is the oxidizing agent. Then now just separate for first oxidation reaction have written. Now you have to write the this things reduction reaction. Half reduction reaction now you have to write. Then here what you have to do, chromium Cr2O7, okay. Then in Cr2O7 chromium has plus 6 oxidation state. You can calculate, no problem, now you are knowing how to calculate. Then in Cr2O7 chromium per atom I am talking about, Cr2 is there but per atom plus 6, and oxygen you know it is -2, already you know. And then this chromate ion actually it gives chromium ion Cr3 plus it gives, you know all things. Okay. In balanced equation, actually in balanced equation it is in question it will be given, they will ask balance it, then reaction will be given just like Fe2 plus Cr2O7 2 minus, and product side they will give Fe3 plus Cr3 plus. It will be given in question. This equation you have to balance. It is not balanced equation. Then this equation you have to balance. Then for that purpose now you have written, for oxidation you have already written. Now reduction you have to write Cr2O7, then it is giving chromium 3 plus. Then in chromium 3 plus, obviously it is a +3 oxidation number. You write the oxidation number of all atom. Okay, then chromium you have written +6, easily you can calculate. Say Cr2O7 is there, then 7 minus 2, 14. 14 minus 14 is there, means Cr2 means 2x. 2x minus 14 is equal to -2. Then minus 14 will go right side, it will become plus 14. Plus 14 minus 2, 12. Then 2x is equal to 12. Then x is equal to +6. Okay, this means chromium has oxidation state +6. Then now reduction reaction also you have written. Reduction half reaction also you have, just easily you can write. Then here you will see that chromium +6, now it become chromium +3 in the product side. It means it lost 3 electron. It lost how many electron? Chromium lost 3 electron. Okay, electron you have to consider, and iron has lost 1 electron. Oxidation per atom 1 electron, and chromium lost per atom 3 electron. Okay, then now after that what will you do? What you will do? Then now this 7 oxygen is there, Cr2O7, 7 oxygen is there. Then each oxygen has -2 oxidation number, that you know. Then oxygen you have to balance. Then what you will write, that now total negative charge will be 7 oxygen means 14 negative charge. 7 into -2, then 14 negative. That's why you will write second, that because 14 negative is there, 14 negative is there, then you have to write this thing, 14 positive you have to write. 14 positive you have to write. Then how you write 14 positive? Then now already you are knowing that chromium you have balanced Cr2. Now you usually will write 2 Cr atom wise. Cr2O7 2 minus is there, Then first chromium you balance. Then Cr2, now you can write 2Cr3 plus. 2Cr3 plus. Okay. Now oxygen you have to balance, the 7 oxygens are there. Then how will you write? Then I told you, you have to introduce water, H2O. H2O. Then 7H2O means 7O. Right side you have written, chromium side, 7H2O means oxygen is balanced. Oxygen is balanced. Okay. O7, now you have written 7H2O. Then now 7H2O means 14 hydrogen. Hydrogen is plus charge, H plus. Then now extra H plus came. Extra 14 H plus has come right side, means product side. Then now to balance this hydrogen, 14 H plus, you have to balance. Then left side you have to write 14 hydrogen. 14 hydrogen, H plus. Then now see, right side also 14 H, and right side also 14, left side also 14 H plus. Both will be cancelled. Okay. And oxygen is balanced. Then like that way, now hydrogen and oxygen, particularly to balance the oxygen, you have done all the things. You have introduced the water, and then you balance the hydrogen. To balance the oxygen, you have used the H2O. H2O involved. Correct? Na? Opposite way. Left side was this Cr2O7. The right side you have written H2O. 7H2O. Then 7H2O means 14 hydrogen came extra. Then left side 14 hydrogen you have written. Then both side balanced. For both side it is balanced. Then now main things you have done. Then you have to this you have done. You have balanced chromium also. You have balanced this oxygen also. But now what I told you, now you are doing main step. Main step means oxidation, half oxidation you have written. Fe2 plus is converting Fe3 plus 1 electron. This is the main first step. Okay. Now second step, Cr2O7. It lost how many electron? One chromium has lost 3 electron. This Cr2O7, na? Then here this things, chromium has lost 6 electron. Oxidation number of chromium already calculated, it was plus 6. Then chromium lost, oxidation number of chromium is plus 6. Okay, here in this reaction. Then plus 6, and that chromium is left side, that is the 3 plus. Then 3 differences there. But when you have done, you have multiplied by 2 Cr, then now what happened? That number of electron of chromium became equal. Okay. Means here Cr2O7, 2 minus was there. Then right side, product side total Cr3 plus was there. Cr3 plus. Then now after multiplying 2, it became 6 plus. Correct? Then 6 plus is there. Then now this 6 plus you have to neutralize. Then left side you write 6 electron. Okay, 6 positive charge is neutralized by 6 negative, means 6 electron. Each electron will have 1 negative. Each electron has 1 negative. Okay. Then now 6 positive charge of chromium. Now it is neutralized. You have written left side near the Cr2O7, 2 minus, na? There you have written left side 6 electron you have written. Then positive, negative neutralized. Then complete things, now you have written for the reduction, here you can see what I told you in the beginning. That time ferrous lost 1 electron. And now this chromate has taken 6 electron. Okay. Ferrous lost only 1 electron and converted to ferric 1 electron. But here molecule ion is complicated, Cr2O7. Then it has taken 6 electron, but taken the electron, that is the important thing, it has to take. Chromate has to take that electron. That is no doubt, it can't escape. Otherwise reaction will not take place, because it is a reduction process. Then electron lost by the ferrous and chromate has taken electron, but it has taken 6 electron. Why 6 electron? Now you are understanding. Because product was Cr3 plus, atom you have maintained 2 Cr, then 6 plus, then 6 plus should be neutralized, hence opposite way you have written 6 electron. That is the distance, reduction side, reactant side, and left side you have introduced 6 electron. Your work is over. Oxidation process you have written, reduction process you have written. Now you have to add. Simply oxidation process and reduction process you have to add. Okay. Then now you have to cancel the electron. Then now you will think how it will be cancelled. Then reduction side, in the case of reduction 6 electron is there, but upside oxidation, in oxidation process only 1 electron, and reduction side 6 electron. Then now very easily you can understand, because electron you have to cancel. Then oxidation process you have to multiply by 6. Oxidation process, step 1, you multiply 6 to all, left side, right side. Then it will become 6Fe2 plus, and right side 6Fe3 plus 6 electron. Correct? And then you can add. Now electron became equal. 6 you have multiplied oxidation side, for left and right both side. Then it became, outside you write 6 into right. Complete things you write in a big bracket. Oxidation process complete you write in a bracket. And outside you write 6 because you are multiplying a whole equation. And reduction side you have to not do anything, because that now number of electron is balanced. Other things already it was balanced only in the beginning. Then now after multiplying by 6 oxidation process, now you can add, or one step simplification you can do. It will be easy for you, that you have multiplied by 6, then now you can write, because it is in bracket. Then now you remove the bracket, means you write 6Fe2 plus, sign of arrow, 6Fe3 plus 6 electron. You do like that, and then you add. This is oxidation process and reduction process, both you add. Then 6 electron will be cancelled, and what is remaining? Left side. What is remaining? Right side for both process. Oxidation process, reduction process, left side. What is remaining? You write. And right side, and the right side again, what is left for the oxidation right side, and for the reduction right side, just to write. Correct? Now it is a fully balanced and 100% correct. Okay. Then for this reaction, what I have given example, now it will become final 6Fe2 plus. This is from the oxidation side, plus chromium oxide Cr2O7 2 minus plus 14H. Now you are adding from the reduction side. Okay, 6Fe2 plus came from the oxidation left side. Okay, and Cr2O7 2 minus plus 14 hydrogen, 14H plus, that is from the reduction side. Means left side you have written. Now for right side, 6 Fe3 was there, 6 Fe3 plus from the oxidation left right side, and for the reduction right side, 2 Cr3 plus 7H2O. Okay, then now this is actually a full balanced net reaction. This is called net reaction. And just after writing all the things, just to check it, verify it that the equation is balanced or not, then atom wise you can see, and charge wise also you can see. Then you will find now charge is also balanced, and this thing says atom is also balanced, charge is also balanced. Just simply I am telling you 6 Fe, then here right side 6 Fe is there, 6 Fe3 plus charge later on you can count, first atom you count, then 6 atom Fe and 6 atom Fe3, means Fe is common, both side it is balanced. Chromium Cr2O7, left side Cr2 means 2 chromium, right side also 2 chromium. Left side Cr2O7, 7 oxygen, here 7H2O. Okay, and left side 7H2 means 14, then right side 7H2 means 14, then left side 14 hydrogen, right side 7H2 means 14, and left side also 14. It means all things are fully balanced. You have checked. Then like that way, all reaction, complicated reaction also you can solve very easily. Okay, that also oxidation number method also you can solve easily. Here this method also you can solve, but that looks complicated, but that is also not complicated. Only thing is that is in the last you will get complete balanced. Okay, that it needs practice. Then now I have told about the, you can say these things, half you can say this thing, half reaction method I have told you. Okay, one more example I want to give you, one more example. Okay, then this example that is related to you can say this thing, per magnet. Two more example I am giving you, two more, then it will be clear. Now given reaction is MnO2 1 MnO4 1 minus, given the equation is MnO4 1 minus, okay, plus iodide ion, I just like chloride ion, iodide ion is there, I 1 minus, both are aqueous solution. Product side it is giving MnO2, MnO4, now it is converting to MnO2, and I minus 1 minus is now becoming I2 solid, S, iodine, I means iodine. Then now this equation is there, given equation in examination, and this equation they will give this type of, you have to balance it. Then so many things you have to do in your mind. Okay, mind, or sometimes in subjective examination you can solve it. Then now how will you solve? Same process you have to follow. Okay, then Mn oxidation, first you find out who is losing the electron or how many electrons they are losing. Then MnO4, if you calculate the oxidation number of Mn in MnO4, very easily you can calculate. MnO4 1 minus is there, then oxidation number of oxygen is -2, then -2 into 4, -8, then X MnO4, for Mn you consider X oxidation number, then X -8, that is equal to -1, because on iron 1 minus is there, equal to -1. Then -8 you take to the right side, it becomes +8. +8 -1, that is equal to 7. Then x is equal to +7. Then oxidation number of manganese is +7. You write at the top, at the head. On the head or upside you write +7. Oxygen, you know, it is -2 and I is already -1. And in MnO2, what is the situation? MnO2, it is clear, means 2MnO2. Then 4, oxygen is total 4 negative, -2 into 2, -4. Then Mn will be +4. Charge which should be neutral. In a molecule, neutral molecule, MnO2 is a neutral molecule, no charge is given. Then -4, 2 oxygen means -4, hence Mn will be +4. Then now you can see Mn was +7, now it became +4. It means it got 3 electron. It got 3 negative, it got, that's why +7, now it become +4. It is taking the electron. It is taking the electron. Then it is oxidizing agent. Oxidizing agent takes the electron. Okay, and who is it? Then this is the, it is oxidizing agent. Mn become oxidizing agent. It is losing, and iodine obviously it will take the electron. Then for I2 now you will consider, then I was -1. Now I -1, now it became I2. I2 0, because for the solid oxidation number is 0. I2, Cl2, F2, or for any gas N2, H2, O2, it is 0. Okay, and for the metal also it is 0. Maybe lead, maybe Hg, maybe nickel, maybe any other metal, iron, metallic state, it is 0, don't forget. Then now you can see you have this iodine, it was having -1, now it became 0. Then it has lost, that ion has lost the electron, 1 electron lost, it became 0. Correct? Then loss of electron means processes oxidation. Processes oxidation, and it is called reducing agent. Oxidation process means reducing agent, reverse. Okay, don't forget, reverse way. Agent means reverse way. What is the process? Reverse way you think, that is agent, reducing agent. Okay, then now you have seen one is losing, other is you can say taking. Then first you write oxidation process, oxidation, then I -1 is converting into I2, correct? I -1, oxidation process, loss of electron, that you keep in mind. Then I minus, it is converting into I2. Then this side 1 iodine is there, other side 2 iodine, I2. Hence first you have to make it balance. This side you do 2I. Left side 2I, right side all I2 is already there. Correct? Then it means what? Electron, how much electron it lost? 2 electron, because 2I, 1 electron lost. Then 2I, 2 electron lost. Hence you can write 2I minus, that is equal to I2 plus 2 electron. Okay, I2 plus 2 electron. Now after that come to the reduction. Then before coming to the half reduction, before writing the half reduction, that you atom wise you balance it for both process. For oxidation process also balance it atom wise, and for the reduction process also balance by you balance it atom wise, and then you write half reaction. Okay, half reaction oxidation, half reaction reduction. Before writing you balance it atom wise, then you write Okay, then it will be very easy, only in 2 steps. Then just like iodine you have balanced, like that way. Now this also you have balanced. MnO4 is converting into MnO4 minus is converting into MnO2. Then here what you have to balance? Then MnO4 minus, MnO4 minus, now it is converting to MnO2. Then already you have calculated, it is the +7 and that is the +3. Okay, this +4, MnO2 +4, Mn is a +4. Now first you have to balance the atom wise, then you come to write a half reduction. Then here you can see oxygen is 4, here oxygen is 2, left side MnO4 minus 1 minus is there, and MnO2 there is a 2 oxygen. Then there is a difference of 2 oxygen. MnO4 4 oxygen is there, left side MnO4 1 minus, left side, and right side MnO2 only 2 oxygen is there. Then there you have to add 2 more oxygen should come, that side 2 more oxygen should come. Then what I told you, either for hydrogen or oxygen, to balance it you have to introduce H2O. Now how many H2O you will write there? 2 oxygen you require. It means 2 H2O you have to write, then 2 oxygen will come, and then 4 hydrogen will be extra. Unnecessarily 4 hydrogen is coming with water. Then okay, oxygen is balanced, 2 H2O, 2 H2O, 2 O came. Then now oxygen is balanced both sides, right side and left side. But 4 hydrogen came extra, 4H plus right side came. Then left side you write plus 4H plus, left side also you write. Then hydrogen will be cancelled. Right side 2H2 have written, means 4 hydrogen extra came, 4H plus came around with H2O. H2O writing at 2H plus O minus. Charge is balanced, na? H2O, oxygen H2 minus, and hydrogen 2 plus, 1 H plus, that is H2O. In H2O, 1 H2O, 2H is there, H plus, and oxygen has 2 negative. Then for 2H2O, 4 hydrogen plus. Then right side you have introduced 2H2O, and the left side plus 4H you write. Then now hydrogen is balanced. Now you write half reduction reaction. Now half reduction, now you can write both together, you write balanced way. Oxidation you have written, already it is balanced, 2I minus, that is equal to I2 plus 2 electron. When you will write the electron only, then it will be called half cell, not a half reaction, half oxidation. If you are writing the electron only atom, when you are balancing, that time it is not called half oxidation or half reduction. Balancing time, atom wise balancing is not called oxidation or reduction. When you are writing electron, only that time it is called oxidation or reduction, because oxidation reduction process is related to loss or gain of electron. Then now you write the half oxidation, then 2I minus, after that arrow sign, I2 plus 2 electron, because 2I minus, 1I minus lost 1 electron, 2I lost 2 electron. Hence now half oxidation, it became like this, 2I minus, and that became now I2 plus 2 electron. Then oxidation you have completed, written. Same way now you write reduction. then already oxidation number you calculated. Then plus 7 was there. MnO4 1 minus, then oxygen was, manganese was having plus 7. Okay. Then now here you have seen plus 7, and right side here it is oxidation state I am talking about. Top you have written here simply you have given NO4 1 minus. Okay, you have calculated because who is oxidizing agent, who is reducing agent, to know that purpose, how many electrons they are losing for that purpose. Now MnO4 only one negative is there, that is important here, and that side MnO2 is there, no charge is there. Okay, then but oxidation state is plus 4, and this side left side plus 7. Then 3 differences there. Then who have taken this electron? Then you have seen iodine lost the electron. Oxidation process or reducing agent, you can tell that is lost the electron. And now who is taking? Then oxidizing agent, means reduction process, there this electron is going to be taken. Then but how many electrons it will take? It is taking. Then chromium side, manganese plus 7, and right side plus 4. Then 3 differences there. It means you write 3 electron left side, because 3 electron manganese MnO4 minus 1 MnO4 magnet ion, that is taking 3 electron. That's why MnO2 become plus 4. Then this 3 electron is taken by oxidizing agent, means MnO4 1 minus. They have taken this electron always. Oxidation easily you can know, loss of electron. Then what is remaining? That will gain of electron. Then what is the change in oxidation state? That you have to write. With this oxidizing agent, means reduction process. That side, left side you have to add, means plus 3 electron you will add, and add plus 3 you write, and then oxidation process, reduction process, just you add both process, oxidation and reduction you add. But again, before adding, what you have to do? Electrons should be balanced or not. Then you have seen that there is a oxidation side only 2 electron is there, but here 3 electron is there. In the reduction process 3 electron is there. Oxidation process 2 electron is there. Then both should be cancelled or not? Both should cancel, because in net reaction it should not appear. Then what will you do? Very easy method, you might be knowing. Then you have to do such way, you have to multiply in such a way that number of electrons should be equal in both process. Then for this easy method is there. Down is 3, then multiply by 3 up. And up 2 is there, then multiply down by 2. Then 3 into 2, 6. And here 2 into 3, 6. Okay. Then oxidation side you multiply by 3, because down 3 is there, 3 electron reduction. Then 3 into 2, 6, and down reduction side you multiply by 2, then 2 into 3, 6. Then in bracket you do all the things. All oxidation process write it first in a bracket, and outside you write 3. And reduction process also write complete things in bracket, and outside write 2. Then one more step, just for simplification, you are simplifying. Then you add. Then now what will happen? 2I minus was there in the beginning, you have multiplied by 2, then it become 4I minus, 4I 1 minus, and that side it will be 2I2, 2I2 plus what will be there? You have upside, you have multiplied by 3, the 3. Then it will come 6I, 3 into 2. Whatever will come, you have to write. 3 into 6I minus, and that side 3I2 will write, and 6 electron. And down same way, you have multiplied by 2. Then 2 MnO4 1 minus plus 6 electron, and after that it will come 2 MnO4 right side, 2 MnO2. Okay, now we add it, cancel the electron, and left side, what is left out after cancelling the electron, you write, and right side what is remaining, that you write. That is the balanced equation. Means here you will get final equation 6I means 6 iodide ion plus 2 MnO4 means 2 magnet ion, 2 MnO4 1 minus, that is equal to 4H2O. 4H2O already you have introduced, that will be there. What is remaining, that you have to write, and plus 3I2 oxidation side, it was 3I2, and plus, actually I told you what is remaining, all things you write. Then left side 6 iodide ion plus 2 MnO4 1 minus plus 4H2O, because where it was required, that side oxygen was required, that side you should write the water molecules. Okay, then now write what is remaining, all things to write. Then right side 3I2 plus 2 MnO2 plus 8OH. Here again I am telling you that these things here reaction you have to check it whether reaction is a acidic or basic. Okay, then question was there, permanganate 7th ion is in a basic medium. Question they have given in basic solution. Then in acidic solution, H ion you have to introduce. In acidic solution, H ion you have to introduce. Then you have to balance. But water molecules you have to write in both cases. But in acidic medium, H you write opposite way. And in basic medium, OH you have to introduce. Okay, OH. Don't forget, in the beginning already I told you. Okay, in basic medium OH ion you have to introduce. And when OH ion you are writing to balance the O, then obviously H ion is related. Then that because suppose you have 4 oxygen was required. As for example, 4 oxygen was required, then 4H2O you have to write. Then 8 hydrogen will be 8 hydrogen will be extra. But here you will write OH ion you are introducing. OH ion you are introducing basic. Then here 4 OH was required because 4 oxygen was lagging behind. MnO4. MnO2 was there. Okay, MnO2 was there, 2 oxygen was there, and this side MnO4 was there. MnO4 left side MnO4 4 oxygen was there, and here MnO2 then 2 oxygen was there. Correct? Then here you have to balance the oxygen. Then actually this 4 OH you have introduced that time. Then 4 OH and you have multiplied by 2 all equation balancing time. Then like that way 8 OH is there. Then to balance the 8 OH you have used 4H2O. then what will happen? Actually required only 4, you can say total oxygen should be both side equal. 4 oxygen left side, 4 oxygen right side. Then MnO4, 4 oxygen was there. MnO2, only 2 oxygen was there. Then left side total 4 is required. Then what happened here? You have added 8 OH. Why 4 OH? Why? Because that 2 OH required, 2 oxygen is required, but you have written 4. Then 2 extra is going on. That's why, because extra you have written, that oxygen also must be cancelled. That's why here right side you have introduced OH ion. Then left side it should be cancelled both hydrogen and oxygen. That's why left side you have introduced, you can say 4H2O. 4H2O. Then there was 8 OH minus hydroxyl ion. 8 OH means 4 O extra was there. 4 O extra was there. And 8 hydrogen extra was there. 8 hydrogen, 8 H plus extra and 4 oxygen extra was there. That's why when 4 then 4 H2O you will write, then 4 oxygen balanced and 8 hydrogen also balanced. Then left side you write 4 H2O. Left side 4 H2O means hydrogen is also balanced and extra 4 oxygen also balanced. You have to apply some common sense, okay, during balancing. Then now it is a complete balance, means 6 iodide ion plus 2 MnO2 plus 4 H2O, that is equal to 3 I2 plus 2 MnO2 plus 8 OH minus, all are in aqueous solution. And this is the balanced reaction or equation I have told you. Okay, now today I am stopping only here. Again next class we will meet with other terms. Okay, thank you.